Okay, we're going to look at some easy series, looking at how the idea of a series is something we actually have dealt with before. What we look at first is that 1/3 we know is 0.3 repeating, or written as 0.333 ... Now one thing to mention is there are a lot of math hidden in the ... The idea is that there are lots of approximations to this. There's 0.3, there's 0.33, there's 0.333, so on and so forth. Each of these is an approximation of 1/3, but none of them actually equal it. It's only if I continue this process on forever do I get to the actual value of 1/3. We can see this through the calculations that I'll show you right now. This equals 0.3 plus 0.03 plus 0.003 on forever, which equals 3 times 10 to the negative 1 plus 3 times 10 to the negative 2 plus 3 times 10 to the negative 3 plus ... Or, now using a summation, this is the sum from k equals 1 off to infinity of 3 times 10 to the negative k. If I want to invoke the series formula from section 9.2, I'll have to write this in terms of a constant multiple. This can be rewritten as the sum. Oops, sorry, let me write that again. Sum from k equals 1 to infinity of 3 times 10 to the negative 1 to the k, or the sum from k equals 1 to infinity of 3 times 1/10 to the k. So this is the way to write the fraction 1/3 as an infinite series. To see that this formula does validate this, we're going to go and push this formula through. In this formula, A is the first term, and this is the ratio. So I can use this quickly then. The first term is 3/10. 3 times 1/10 of the first is the first term of this situation. Over 1 minus the ratio is 1/10. Notice that the 3 does not appear in the bottom. The ratio is simply the 1/10. If I then clean this up, I get 3/10 over 9/10, or 3/9, or 1/3. That's just a quick little video talking about series you have seen before and going back to section 9.2 to look at how they actually verify that result. Thank you.